Hello everyone, we are from Group 4 from J4EM1102F, far from Workshop Practice 1, Session 2026, Faculty of Mechanical Engineering, Yaitan Pasir Gudang. So, my name is Putra J4EM1102F.
My name is Sudana Rahma binti Ahmad Basri.
My name is Muhammad Wazif Ibarul Islam.
My name is Muhammad Osman Kamaruddin.
So, for this case study, we selected the sheet metal workshop, a core facility where students learn to fabricate three-dimensional metal parts from flat metal sheet. Based on our MEM161 lab manual, the practical here involved working with 0.5 mm galvanized iron sheet through 4 main operations: marking, layout, shearing, bending, and riveting. So, why does this matter? Because while this process build essential engineering skills, they also carry real safety and environmental risks that we need to take seriously. So our objective is describe current safety and sustainability practice in the sheet metal workshop. 2. Identify technical, safety and sustainability issues from our operations. 3. Propose solutions with referencing OSHA 1994, FMA 1967, ISO 14001, 2015, and MS 1722, 2011. 4. Evaluate trade-off between cost, safety, and the environment. 5. Recommend continuous improvement for our workshop. So, let's get started.
So first of all, before we get into our workplace, let's appreciate the available things that are already done in our workplace, which is following PPE protocols, which are having jackets, thick pants, and safety boots. There are also several safety or yellow safety lines across the workshop. And lastly, we have several safety signs for some reminders for the student.
Okay, so the first one is PPE. Our lab manual lists safety goggles as mandatory for every student entering the workshop. Goggles protect against flying method and soft during shearing and during drilling, and sharp fragment during filling. Okay, so for the second one is lab manual. Directly tell us a quite procedure. Keep your hands and other body parts away from moving blades during the cut process. This is an important safety instruction built right into step 7 of the cutting procedure. Okay, so the third one is the curtain sheet. It's equipped with holder bar, up to safety cover, front and side gauge as shown in the machine diagram. These are physically cuts that reduce accident blade contact. 4. Use a head file to remove sharp edges so the riveting procedure will be easy. Also, the workshop has a safety sign, first aid kit, fire extinguisher, and run resection safety briefing before practical.
Despite those good practice, we have identified a few issues. We have detected a few issues. One of it is there is no sticker of regular calibration on each machine. Basically, regular calibration means that there will be like some kind of inspection on the blade, so they can check the real accuracy of it. But because there's no sticker on this type of machine, sometimes when we use them, there will be some misalignment and a low accuracy production will be made because of usage of it. The next issue is inconsistent bending. Because of this machine used heavily manually, a lot of human error has happened. Because you use a lot of your human mind, you have to like estimate sometime whether it's 90 angle or 80 angle. After all, we're only human beings. Sometimes human error can be fixed. Alright. The next issue is there is no glove listed as PPE. This is treated with care. The lab manual apparatus list included safety goggle, but cut-resistant gloves are not listed. Yet students can freshly shear galvanized iron with razor-sharp edge using bare hand to transfer the blank from Golden to bending machine. This can cause a lot of problems such as injury, But I think when you handle this type of metal, alright, next. Right. The next issue is zinc dust from galvanized iron. When you drilling and do shearing, filling and stuff, this galvanized iron will produce some particle on the air. This will cause you some trouble on your lung when you inhale it. And the next issue is galvanized iron end up mixing with a general waste. This causes it to reduce in recyclability.
Okay, so now we are going to the next section, which is the proposed solutions and standards we must follow. There are several solutions that we have provided for the problems that we have found. So first of all is that on each of these machines, which are guillotine and the bending machine, is that we must provide proof or sticker or regular maintenance schedule so that each machine is properly maintained before every session starts. Either a sticker of proof is already enough, or a schedule to as also proof of the machine has been calibrated regularly on a regular basis. So this aligns with one of the standards, which are FMS 1967 Regulation 11, which requires all machinery to be properly maintained. So next up. Okay, so for our next proposed solution is to add cut resistant gloves mandatory for every lab manual apparatus list. As for why, this is to prevent accidental or further accidental cuts on our hands, especially after using the guillotine machine or during the workpiece. So this is supported by OSHA 1994 Section 28 on employee PPE obligations and MSFT 22 2011 Clause 442 on training and awareness. So for our next proposed solution is focused directly on the drilling machine, where when we are using the drilling machine on our metal workpiece, some or maybe a little bit of dust particles may flow into our air respiratory system, which can be harmful. So we propose solution to make a local exhaust or some sort of ventilation system to prevent some sorts of fumes of the metal workpiece from getting into our nose. So this satisfies the OSHA 1994 Section 15 and FMA Regulation 26 on adequate ventilation, along with ISO 14001-2015 Clause 81 on controlling environmental aspects including air quality. Okay, so for our final solution as to our problems is to have another or a proper separational bin that separates between the scrap metal and other junks, which specifically for scrap metal should be purple in color. So why do we need this? It aligns with ISO 14001 for clause 8.1, which requires organizations to establish, implement, control and maintain the processes necessary to meet environmental management system requirements. That's all.
Now, we have to be honest, implementing this solution isn't without conflict. So the first conflict is cost versus safety. Installing LED and upgrading the gluten costs money. The budget also may be limited, but doing nothing, it costs more. One serious injury can lead to the medical cost, legal issue under OSHA 1994, and damage to the faculty reputation. So the second one is section time versus sustainability. The nesting plan at one extra step before cutting, but it prepared before the practical section. Students can complete it during a lecture or tutorial. This saves time during the lab and reduce material waste. So the third one is short-term versus long-term benefits. Checklist and waste segregation take extra efforts at first, but once students understand why, they are more like to follow the rules. They learn that dust can damage the lungs, and they also learn that mixed scrap cannot be cycled efficiently. With support from lecturers and technicians, these habits become part of the workshop culture.
So let's break it out again. The sheet metal workshop and the demonstration ground is a well-equipped, actively used practical facility. It has safety goggles, machine guards, procedural safety instructions, scrap collection, and LED lighting, all informations. But our analysis identified 4 issues that leave significant gaps, particularly the absence of glove in the PPE list, the foot pedal activation list on the guillotine, zinc dust from galvanized iron operations, and material waste from unplanned cutting layouts. Our solutions are maintenance schedule, mandatory glove with formal labeling, local exhaust ventilation, and nesting with waste and energy protocols. All are grounded in FMA 1967, OSHA 9494, ISO 14001 2015, NMS 1722 2011. Finally, no standard, no regulation, and no engineering solution works without the people inside the workshop choosing to act responsibly. When we, as engineering students, put on our PPE without being told, plan our cutting to minimize waste, and switch off machines when they are not in use, we are already practicing the values of safe, sustainable, and responsible engineering. That is what MEM161 is training us to become. And that is what Malaysia's in engineering industry needs us to be. That's all for us. Thank you for watching. Bye.